All right, so we're going to talk about Chapter 1, Section 3, and it kind of goes more in detail about how we can describe quantitative data um, using different parts of the data. Yesterday was more about the graphs, and we talked a little about shapes that are spread and outliers. We're going to go more in depth about the center and the spread. So the first thing I want to talk about is the mean. So we have two symbols that represent mean. The first one is this X with a line over top of it, and we call this X bar. So X bar is the mean of our sample. If we're talking about the mean of our population, we would use this symbol, which is the Greek letter mu. Okay, so for the most part, X bar is the one we'll use as we get later on into chapters and we start talking more about significance tests. We'll use mu a little bit more. That is an arrow, and it looks very ugly, so I'm going to erase it. Oh, well, let's just mark it out. There we go. So don't get hung up on the variables too much right now, but just know that they are pronounced X bar and mu, and X bar is for the sample and mu is for the population. We'll talk more about the difference between sample and population later on. One thing you do need to know about mean is that it's sensitive to the influence of extreme observations, meaning if you have a skewed distribution or if you have outliers, it's going to affect your mean. So that's why we typically use the median when we have skewed distributions or distributions that contain outliers, because they will pull our mean away from the true value of our average. So the mean is not resistant. It is not a resistant measure of center, so therefore we can't use it when our distributions are skewed. I mentioned that the day before, but we're going to go in a little more detail with that today. To find our average, the formula on your formula sheet says X bar equals sigma of X with a subscript I all over N. So let's just talk about each of those parts. The sigma means to add up. Xi means each observation. So the numerator is just the sum of the observations. And then N is the number of observations that we have. So we would divide by how many observations, and we would get our average. Hopefully you remember this formula from 5th grade, 4th grade, whenever you learned how to find average. It's probably way back there somewhere. And we'll learn how to do this on the calculator today. So the next thing when we're comparing mean and median, you don't want to confuse the terms. A mean is your average value, whereas the median is our typical value. So when we're describing these, don't say that the average is a typical value. It is definitely how we would describe the median. If you have a symmetric distribution, then the mean and the median are close together. This is roughly symmetric. If it's exactly symmetric, then the median and the median would be exactly the same. And if you have a skewed distribution, then the mean is going to go out towards the tail. So if you skewed right, then your mean would be higher than your median. If it's skewed left, your mean would be lower than your median. So I want you to take a minute, pause the video, go to page 55 in your textbook, and try to check your understanding. All right, so the first question asked if you would expect the mean travel time to be less than or about the same as or larger than the median. Since this distribution is skewed to the right, we would expect the mean to be larger than the median. The second question asks you to actually calculate these numbers. So when you do the calculations, the mean is 31.25 and the median is 22.5. So the mean is larger than the median. So we were correct in our assumption. The third one says to interpret. This is really key here. You may not have known how to do this, but when you're asked to interpret a mean, this is how it would be in context of this problem. If we divided the travel time up evenly among all 20 people, each would have a 31.25-minute travel time. So that is our interpretation in context of the problem. And then the fourth one, it asked you which one would be more appropriate. In this case, since the distribution is skewed, the median is a better measure of the center of the distribution. And I told you that in our last lesson, and now we're kind of going into why that is. So I want to go through an example on how to calculate mean and median. So this is the commuting times of 20 randomly selected New York workers. This was the problem you just did for the check your understanding. So I just want to make sure that you know how to do your averages. So for mean, we would just add up all the values. So starting over here on the left, the 10, the 30, the 5, you would add all the way up to the 45. And then you would divide by the number of data, and that is 20. So that equals 31.25. You always want to show your work. You don't have to list every single piece of data out. Notice how I put the ... in there. So list the first few, ... and then the last few, and then put it over the number. So that is the best way to show your work without having to write out every single number. For your median, once you order the data, it becomes a lot easier. Since there's 20, then the 10th and the 11th piece are going to make your median. However, you have to take the average of them. Since there's not an exact middle, we would do the average of the two that fall in the middle. So 20 plus 25 divided by 2 is 22.5. The next thing I want to talk about is the interquartile range. So when we do a box plot, we have to find the first quartile, the third quartile, and that will give us the interquartile range. So once you find your median, it splits your data in half. Half of the data falls below the median, half of the data falls above the median. So then once you split the data in half, then you split it in half again. So the middle of the bottom half is the first quartile. The middle of the top half is the third quartile. So it's almost like you're finding the median of the bottom half and the median of the top half. Then if you were to subtract those values, Q3 minus Q1, you would get your interquartile range. So here's an example. That same problem we just did. We found the 22.5 as the median. So then we look at the bottom half. The lowest is 5. The highest is 20. Oh, wrong 20. That 20. Okay. So 15 and 15 would be the exact middle. There's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the average of these two would be our Q1. Well, the average of 15 and 15 is 15. So same thing here. I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the average of 40 and 45 would be my Q3. So once I found Q3 and Q1, I subtract them. 42.5 minus 15 gives me my interquartile range. So that if you're ever asked to interpret your interquartile range, you would say it's the range of the middle half of whatever your problem's about. So this is about travel time. So the range of the middle half of travel times for the New Yorkers in the sample is 27.5 minutes. So if I'm going to identify outliers, then I would follow this rule. I multiply my interquartile range by 1.5. Oops. All right, sorry about that. I would multiply my interquartile range by 1.5. Sorry, my pen keeps messing up. So when I multiply 1.5 times, and we're going to use that example, by the interquartile range of 27.5. There we go. All right, we're going to try this one more time. My pen keeps messing up. Okay, so 1.5 times 27.5, we get 41.25. So then we're going to subtract that number from Q1, and we're going to add that number to Q3. So if there's any value that falls below negative 26.25 or above 83.75, then it's an outlier. So 85 is above 83.75, therefore 85 is our outlier. And so we can now officially say 85 is an outlier. We no longer have to say potential because we actually did the calculations to prove it. So the next thing I want to talk about is the 5-number summary. Your 5-number summary would just be listing out your minimum value, Q1, your median, Q3, and your maximum value. And you would want to write them in order from smallest to largest. A lot of times when you're comparing distributions, you're going to be given the 5-number summary of each distribution, and you would have to compare the values in each one. So here's the same example that we've been working with. We know our 5-number summary, and so from that 5-number summary, we can create our box plot. So the minimum value would be the first part of the box plot down here, which is 5. Q1 would be the first part of the box. The median would be the line in the middle of the box. Q3 would be the end of the box. The maximum value is typically the end of the box unless it's an outlier. So since 85 is an outlier, it goes out here, and 65 would be the end of the box. And so that's how I take my 5-number summary and create it into a box plot. So go ahead and try to check your understanding on page 61. Pause the video, take a few minutes, and then we'll come back and check. So the 5-number summary, your minimum was 307, your Q1 was 311, your median is 317.5, your Q3 is 326, and your maximum is 353. If you have any questions about that, you can ask me tomorrow in class, so just make a note of it if you need to. The second part said to calculate the IQR. So the interquartile range would have been 326 minus 311, which is 15. So this is the range of the middle half of the weights of Dallas Cowboys offensive linemen in 2009. So that would be the interpretation of it. So to determine if there's any outliers, we would take 15 and multiply by 1.5. We would add it to 326, and then we would subtract it from 311. So if there's anything that falls outside of 288.5 or above 348.5, then it would be an outlier. And there was one, 353 is above 348.5. Therefore, it is an outlier. The fourth part said to draw a box plot. I want to go through the steps of how to do this on your calculator. So I've typed in all my data into L1. Remember, we click Stat and then Edit. Let me show you again. Stat is right there, and then Edit. Type all your data into L1. Then we're going to go to the same place that we did the histogram. Second, Y equals. Go to plot 1. We're going to make sure it's on. Then we're going to go down here, and right next to the histogram is the box plot. You see it with the 2 little dots? That means it's going to do it with outliers. If you do the one beside of it, it will not do your outliers for you. So I'm going to select that. And then I have to go to my window. In my window, I want to make sure it's big enough to see all my values. So I think I don't have anything below 300. And I don't have anything above, let's see, 360. And then your scale can just be 1. It's not like a histogram. You don't have to change your bandwidth. So then I'm just going to click Graph, and it's going to show my box plot. If I want to know the value of each line, I would just click Trace. So there's my minimum at 307, Q1, median, Q3, And then this is just a value. It's not technically my maximum because my maximum is an outlier. So there's my maximum, but it is an outlier. So this is a way you can kind of check to make sure that you did your outliers correctly by hand, is making a box plot in the calculator. It will do the outliers for you. So going back, all right, so the next thing we're going to talk about is another way to measure spread. So far, the only two ways we've learned how to measure spread is range and interquartile range. So there's one more that we can use to describe the spread, and that's the standard deviation. So when you're trying to find the standard deviation, the first thing you need to do is calculate the mean. So I've got some data here. The mean, if I added all these up and divided them out, I would get the mean of 5. So then I can look at how far each data value deviates from the mean. So let's look at 8. Okay, 8 is going to be 3 away from the mean. 8 minus 5 is 3. And if I go on this side and pick one on this side, 1 is negative 4 away from the mean. So I would have to do that for each individual piece of data. So I'm going to make a chart. So if I find the deviation of each one, that would be subtracting the mean from every data piece. So my first data piece is at 1, and I would subtract 1 minus 5 to get negative 4. The second data is at 3, so 3 minus 5 is negative 2. So on and so forth all the way through. Well, if I were to add these up, my negatives and my positives would cancel each other out, and so it would pretty much just be 0. So before I add them together, I want to square them. So then I can kind of get the average deviation from the mean. So I no longer am going to equal 0, I'm going to get a number. So if I add all of these up, this is actually called my variance. I still have to divide it by how many observations I have. But instead of dividing by 9, I'm actually going to divide by 9 minus 1. And so I get 6.5. That's my variance. And then the standard deviation comes from taking the square root of the variance. So my standard deviation would be the 2.55. So let's go through that again. To find standard deviation, you find how far it deviates from the mean. So you're going to subtract the mean from every data point. That would be this chart right here. All right, sorry, I had to realign my board. So the first step is to find how far it deviates from the mean. So I would take each data point and subtract the mean, and that's this chart. Because I have positives and negatives, if I were to add them all up, it would probably be approximately 0. So I'm going to square them first before I add them all up. Once I add them all up, I'm going to divide by n minus 1. The number of observations, subtract 1. And the number I get here is called the variance. Once you know your variance, you take the square root of it to get your standard deviation. We talked about the symbols for mean. For sample, it's x bar. For population, it's u. So for standard deviation, for the sample, it's s with a sub x. And then for population, it's sigma. So make sure you go ahead and learn those symbols as well. So here's your formula. And they show up on your formula sheet like this. So there's your symbol for standard deviation. Your symbol for variance is that same symbol but with an exponent of 2. So this right here, the 1 over n minus 1, that's pretty much the same. Divide by n minus 1. The sigma means add them all up. And this is the deviation. So this is each individual observation. This is your mean. So each individual observation, subtract the mean, square it, and then add them all up. And then once you add them all up, you divide by n minus 1. So that's pretty much each step that we went through. And it is all under a radical because you have to take the square root of it for it to be the standard deviation. So we talked about yesterday when to use mean and when to use median when describing the center. That goes along with standard deviation as well. If you're using the mean, then you would say the standard deviation for your spread. So mean and standard deviation are kind of like partners when describing center and spread. Median and IQR are usually better when it's skewed or there's outliers. You can still use your range in there for either one, but at this point we're going to limit it to the median and IQR when it's skewed or with outliers, and we'll use mean and standard deviation when it's roughly symmetric. So go ahead and take a second and do the check your understanding on page 64. All right, so the first problem in the check your understanding, I want you to find the mean and then interpret it. So if you added them all up and divided by 5, your mean would be 7.5. So the interpretation would say, if the total of all heights was the same, but all the players were the same height, they would each be 75 inches tall. The second part says to give a table of the mean and its square deviation, the standard deviation for the values in your table. Show how to calculate it. So I started the table over here. Each data point is listed under the xi. So remember, xi represents each individual data point. So then the deviation, I would take each data point and subtract the mean. So 67 minus 75, and then 72 minus 75, 76 minus 75, 76 minus 75 again, and then 84 minus 75. So if I were to add these up, it's going to either equal 0 or be pretty close to 0. But that data of adding those up is meaningless. So that's why we have to square. So if I square each of these, I get 64, 9, 1, 1, 81. Then I add these up. You always have to add the square differences. So 156 divided by n minus 1. I had 5 pieces of data, so divided by 5 minus 1. 156 divided by 4 is going to be the variance, so 39. Once I find my variance, then I'm going to take the square root of it. So the square root of 39 is 6.24. That would be my standard deviation. So standard deviation is 6.24. The variance is 39. The last thing it tells you to do is to interpret the meaning of the standard deviation. So the standard deviation is just an average variation. So the player's height vary about 6.24 inches from the mean. All right, make sure you jot down any questions you have, and I'll answer them tomorrow in class. Thanks.